So we're going to do the reaction of carboxylic acids with alcohols. We need two functional groups to do this esterification. So we need a carboxy group to accomplish this. So just reminding you and giving you that visual, that's the C double bond OH. Okay? You're going to get that in a carboxylic acid. In tomorrow's lesson, we're going to actually later, the second lesson, which is going to be later today, we're going to look at carboxylic acids that have two of these functional groups and can connect twice. Okay? And those lead to polymers and long chains. But right now, we're just going to look at carboxylic acids that have one carboxyl group, and we'll look at alcohols that have a hydroxyl group. Okay? When we get that combination, the organic, the carbons are all going to show up in the ester, and we get an H and an OH spit out. Okay? So you need to be familiar with that term for this type of reaction. Okay? You do need an acid catalyst. When we get to the lab, it's important that you get me to add that sulfuric acid, or the esterification reaction doesn't occur. Okay? So let's finally get to an esterification. So my carboxylic acid is going to be propanoic acid. That's going to react with methanol. Catalysts typically go above or below arrows, so I'm writing the catalyst needed for this reaction. Sulfuric acid is the one we're going to use in the lab today. Again, you don't need to know or memorize any mechanisms, but I have been talking them a little bit. You're going to see them in university in organic chemistry, and they help you understand what's going to happen. Okay? You're going to end up, it's more complicated than what I'm about to present, but the heart of it is a lone pair on that alcohol will be attracted to that positive carbon. This is a very polar bond. The more electronegative atom is the oxygen around it. So this is slightly electropositive, and there's a pair of electrons, two full electrons, and that's what starts this reaction. Now you do need the acid catalyst to help it. Okay, so that's useful for students to realize this O is going to connect to that blue C, and that's how you put it together. Okay? But again, you don't have to draw any arrows in this course whatsoever. Now I'm going to switch colors. Now I've switched over and the alcohol piece has connected. So that O has gone to that C. The color coding also helps when we go to name it. When we name alcohols on the next slide, you get one name from the alcohol piece, which I've made black, and you get a second name from the acid piece that I've made blue. Now what's left over? This isn't balanced yet. What parts came off? Perfect. You have an H. Yeah, you have an H. That H hasn't been accounted for. And we've got an OH. And back on the top, I said we get an ester and water. So this is our ester and water. Esters should be fairly easy to pick out. They're the only hydrocarbon or hydrocarbon derivative that we've done that have an O in the middle of carbons. Okay? So the correct term for this is hydrocarbon derivative. C's and H's are hydrocarbons. Once you have anything other than C and H, it's a hydrocarbon derivative. So let's jump into how do you name that, or naming rules in general. So as mentioned on the other slide, and I color-coded it, the name comes from the two components that made it up. Okay? You may not have a reaction, but you have to dissect the ester into the two pieces that made it. Okay? The first part of the name is going to look like an alkyl name, end in YL. Okay, and that's going to come from the alcohol. So if the alcohol that made it was, in that example that we saw before, methanol, would have methyl as the first part of our name. The second part of the name is going to be an alkane corresponding name of the acid. So we're going to drop the E and add an O8 ending. Okay. So the previous slide, we have propanoic acid. We're going to go propan O8, and that'll be our second part of our name. So I'm just going to slowly write out the reactants for this reaction. The acid first. I do have to add one little thing that's missing here. Now, many haven't maybe gotten there, but what's missing from that alcohol? Spelling. Yeah, I didn't denote the position, so I'm doing propan 1-all. And you're going to find in this course, we don't deal with branches that come off middles. Okay? So you're going to see all the alcohols that you're asked to make esters with the name are going to be ones that are going to be primary alcohols where the OH is on the end. The question didn't mention the acid catalyst, but I'm going to always write it in. I want you to get used to that you need an acid catalyst for this reaction. Again, you don't have to draw the arrow that I started with, but it's a really good reminder of how to connect these. Find the O on the alcohol, and that's going to connect to the C on the acid. These could be written in either order, so it's important that you get the alcohol and connect that O. It's going to end up with 2 carbons from the acid. We get the O, and then there's 3 carbons from the alcohol. Plus, even students forget water, and I almost forgot to add the water in doing the balance reaction. It's probably the #1 most common error with doing a reaction like this is you lose a quarter mark or a mark out of 2 because you forgot the water. Okay, so let's name this. Okay. When you're going to name it, I often at least visually kind of put a line through the O and realize there's 2 sides. We've got one side with 3 carbons, we've got one side with 2. You name the side that doesn't have the double bond O on it first. That's the alcohol piece. So that is this one. Okay. Do not just always start on the right. Okay. This could be flipped around. So find the alcohol piece. That's a 3 carbon alcohol piece, so we use the alkyl name. So that's propyl. But now we got to name the acid piece. So that's 2 carbons. So we use the alkane name without the final E and add O8. Esters always make me think of oatmeal and like O8 and oatmeal. I don't know why. This is no science connection, but I think of oats. Propyl ethanoate is the name of that alcohol, okay? Regardless of how it's written, how it's flipped, how it's rotated. Alcohol. Any questions before I do? I'll end with the line structure. Question? Within Chem 20, you will not need to include any numbers because we're not going to be doing any secondary alcohols where there's a connection in the middle. In post-secondary, you'll learn words like iso, that means in the middle, or tert is when it's a tertiary alcohol. So, but for Chem 30, no. But within the realm of organic, yes, it could be possible. This one? That's where the water is made from. So if you take this OH and that H, so I'll pick a different color and put an arrow to it, that OH and that H is what makes our water. They get eliminated and pulled out. Okay. And I'm not doing the full mechanism, but the acid is actually going to attach there and help pull that OH off. And that's kind of where the water comes from. Then that H pops off and regenerates our acid. There's no numbers needed, and the question is, could this double bond be there? And the answer is no, it can never be there. The connection has to be from this O to there. So you will always have the ester linkage will always be that. You have to have a C double bond O bonded to an O, that O is bonded to a C. That's an ester linkage. It will never be out of that order because of that connection. So you don't need any number because it's always going to be that order in an ester linkage. Okay. Again, it's not a super common error, but I've certainly seen where students go and put the C double bond over here, and that shows me they don't understand the connection, the sequence that things come together. Nicole? Water ends up being a leaving group in this reaction. The acid protonates it, water becomes a leaving group, and that gets things going. And that's why in the lab, if you forget to have me come around and put the acid into your esterification tube, nothing's probably going to happen today. Okay. Now you do want things to happen today. Esters have they have smells. They're not always nice. We're going to make ones that try to have nice smells. Okay. If you've ever, has anybody ever had banana bubble gum? Nobody? Apple bubble gum? Have you heard of banana bubble gum? Okay. They're all fake. They're all esters. They're made by chemists. There's no banana. There's no apples. If you buy even most mint things, it's not real mint or synthetic mint. One group today is going to make oil of wintergreen in the lab today, that nice minty smell, and it's an ester. Okay, so this is the only lab you're going to do where we're going to encourage you to smell the products that you make. Now you have to smell carefully because you're going to add a concentrated acid and some will be left over. So you're going to waft because you don't want to get that acid in your nose. But if all goes well today, you'll know you've made an ester because you have a nice smell at the end that you didn't have at the start. Okay, and a unique smell at the end would be a sign of a chemical change. Okay. So let's get the line structure out. So I've got 2 carbons. So to get, I drop my pen and go 1, 2, lift. So 1, 2, lift. That's my 2 carbons. I've got a double bonded O coming off the rightmost carbon. Then from that carbon, I go to an O. So I'm going to put a line segment in, but I'm going to end it with an O. There's no carbon at the end of the line segment right next to the O. When you have a letter, it replaces that carbon. So now we're at the O that has the red dotted line through it, and now there's 3 carbons. Okay. I put my line next to the O, but I don't say a number because there's an O there. 1, 2, 3. And that would be our propyl ethanoate. Again, if you're not sure, try circling all the line segments, the endings that don't have a letter at them, and you should quickly see your carbon count. So it looks like, yes, I've done this correct. The carbons pop out once you circle them. I'm going to erase them and leave them out of my notes because they're not part of an actual answer. They're just a strategy. And again, realize you can always draw mirror images. So I could have put the, flip the sides. 1, 2, 3, O. That is also propyl ethanoate. I just put the 3 carbon alcohol part on this side, and I put the 2 carbon acid piece on that side. Either's correct, either's fine. Okay. So I'll talk about the lab in about 10 minutes. Just a few questions for students to work on before we wrap up this section. So the first one is just a drawing. Don't do a reaction. Just draw that. So you're not going to include water. And then down below, I have a full reaction. I'd like you to draw these, and I didn't put it in the title, but I'd like you to name. I did in the bottom say name them. So I'd like you to do that. Draw and